All right, hey guys. Building a deck of cards. It looks like we're going to need a few different classes. The nice thing about this assignment is that it gives us kind of a super straightforward step-by-step process of what to do every single time or at every single point of development, and it's pretty helpful in that way. So the first class that we need to do, create a class called card. Darn. Oops. Okay. Cool. Let me change some stuff real quick. Change my namespace to deck of cards. And I will create a new file called card. Give it the same namespace. And give it a public class of card. Cool. Give the card class a property string val, which will hold a value. Okay, blah blah blah. This val should be a string. Okay, so I'll have a public string called string val. And it'll eventually hold these values in them. Give the card a property suit. It'll be a string. Give the card a property val, which will hold the numerical val. So that'll be an int. Suit and val. Pretty straightforward. Cool. Any questions about what I did so far? Just created a class. It has 3 attributes. All of them are set to public, so I can access them. 2 of them are the typed string. I've given them getter and setter methods for all of them. Pretty straightforward, right?
Right.
Thanks, Jack.
What's happening? Well, the
We're building a deck of cards.
String, right?
Huh?
You said they're all type string?
Sorry, 2 of them should be type string. This one should be type int, right?
Okay.
Cool.
It should be set up to rabbit instead of public,
Why?
so they're not gonna get in and change the value.
Nope. Yeah. Okay, so I think we've successfully completed the first third of the assignment. We've built a deck or a card class, and we've given it 3 properties. We'll probably need to build a constructor function for them to set those values, but we'll do that when we need to. So next, create a class called deck. Will do. New file. Deck.cs. Namespace is deck of cards. Public class deck. Okay, I created that. Give the deck class a property called cards, which is a list of card objects. Cool. So I'll have list of what? What will my list be of? Card objects, right? So I know a lot of people might have wanted to do this, but really, it's not just a what's the word I'm looking for? Not plain. It's not like a default object. It's a card object, right? Card. Card. Need to use collections. Great. Give the deck class a property called cards, which will be a list of card objects. When initializing the deck, make sure that it has a list of 52 unique cards as its cards property. Cool. So we will need to actually build our deck of cards. So how do we create a constructor class? Public, and the same name as the class name, which is how we create a constructor class, right? Oops, so deck. Cool. In here, I'm going to set my cards. I've reserved the cards variable to eventually hold a list of cards, but I have not really initialized that to actually hold a new list of cards, right? So I'm going to set cards to equal a new list of card objects. So now my cards variable actually holds an empty list of cards. And what I need to do is actually put stuff in there. So let's see. 52 unique cards. So I'm going to have a string array called card vals, which is going to equal an array of all of these things, right? Yep. Oops. And I'll have a string array of suits. That will be, what are my suits? Clubs, hearts, spades, diamonds. Excellent. Now what am I going to do?
Generate the deck.
Generate the deck. How? I have all of this useful information stored in my two arrays. I think what I could probably do is run a nested for loop, and for each value in my suits, create a card for clubs of ace, clubs 2, clubs 3, clubs 4, and so on and so forth, right? So I'm going to run a nested for loop here. I'm going to say for int I equals 0. I is less than suits dot length I plus plus. And here I'm going to run another nested for loop, say int of j equals 0. J is less than card vals dot length j plus plus. Oops, that's capital J. And what do you suppose I'll do here, right here in line 14?
Add to the list.
Yeah, exactly. Create the new card object and add it to the list, right? Yeah. So, how do I create a new card object? Card. Oh, I need to first create. I could cards dot add my card, right? But I first need to create my card. Does that make sense? New card. This could be anything. This could be banana.
Do you have to specify the type there? Or
That's exactly right, Michael. This is the type that this variable will be. So I'm instantiating a new card, right? A new card and putting it in this variable. I just need to tell it what type it is, right? Just like how I would say int banana equals 42. Same exact way, right? So type card of variable named card. Let's call this my card so it's a little bit easier to see, differentiate. I'm going to create a new card. Now this card needs to hold specific values. What does each card have to have, or what attributes does each card need to have? A value, yes, a string value, a suit, and an actual numerical value of 1, 2, 3, 4, 5, all the way up to 13, right? Because later, if we're going to create a game where we want to compare a king to a queen, we can't really ask, is king greater than string of queen? But we can ask if 13 is greater than 12, right? So that's why we're also assigning numerical values to these cards. So I want to pass in a string of string val. I also want to pass in a string of suit, right? And I also want to type or pass in an int of int val, right? So what should I pass in for string val here? Maybe card vals of j. What should I pass in for the suit? Suits of I. Anybody out there? And int val, I will pass in card vals plus 1. What's wrong here? Oh, sorry. Card j plus 1. Does that make sense?
Why are we doing that?
Why am I doing this? Yeah, sure. My card needs to have 3 properties. It needs to have a string value. So is it an ace, a 2, a 3, a 4, all the way up to jack, queen, king? It also needs a suit. Is it a king of hearts, spades, diamonds, clubs? And also, what is the actual numerical value that it represents? What does a king represent? 13, right? What does a jack represent? 11. What does an ace represent? It represents 1, right? So they need these numerical values. So each card needs these 3 things. So when I'm creating my deck of cards and I'm adding cards into my deck, I'm just giving it those properties.
Oh, so the order in which they are right now in card values is the number they represent. So the zero-based index.
Yeah. And the reason why I'm doing j plus 1 is because,
Yeah. So
yeah, exactly. 0 plus 1, all the way up to 12 plus 1, which will be 13. Cool. Right now, the way that I have it, when I create a new card, it looks like card does not contain a constructor that takes 3 arguments. What a beautiful error. How specific and helpful. So now I need a constructor in my card object that takes in 3 arguments. Are we all on board so far? Yes, let's go to our cards class and let's create a new constructor then. So public card, and it needs to take in 3 things, right? String called string val, a string called suit, and a int called val. And I'm just going to change these to uppercase because this is probably a good style guide to capital or uppercase your variables and class names and everything else in C#. Cool. So I'm passing these in, and I'm going to set these attributes of my card to whatever was passed into my constructor function. So I'll set my string val equal to what was passed in, that string val. I'll set my suit equal to whatever suit came through as. And I'll set my val equal to whatever val came in as. How are we feeling so far? Good? Cool. So now I'm guessing that my little red squiggly went away because now my card has a constructor that expects 3 parameters to be passed in, right? So now here I will create a my card for every iteration of this for loop, and I will add my card to my cards list up here. We following? So let's test this out. Program.cs. Let's say deck. My deck equals a new deck. Cool. And yeah. So I'm going to put a breakpoint right here So in my debugger, we can maybe observe the contents of my deck. Cool. So I'm going to go to my debugger, run it. It's going to break right there. Perfect. So now here on the left side of my debugger, we have some variables that are available to us. We have a my deck object, and it has 52 cards in there, right? In index 0, we have a card object. In index 1, we have a card object. And if we look at each card, it has a string val of ace, a suit of clubs, and a val of 1. 2 of clubs, 3 of clubs, all the way down to maybe like a queen of clubs with int val 12, king of clubs with int val 13, ace of hearts with int val 1.
I think they have this weird error for some reason.
Okay, I'll help debug, but yeah, for the sake of the video, we're gonna move forward. Yeah. Any questions, though? No? Okay, cool. So we have when initializing the deck, make sure that it has a list of 52 unique cards as its cards property, which we in fact do have. Give the deck a deal method, which selects the topmost card, removes it from the list of cards, and returns that card. So in my deck class, this is my class constructor. I need a new method. Public. What does it return something? The card. Card deal. Cool. And deal selects the topmost card. Cool. So I can say I'm gonna go for 0. So I'm gonna say card equals, what am I gonna do here? Cards of 0, right? So what's being stored in my card right now? The first card, or however way you're looking at your card, the last card of the first card. Right now, I'm just going to think of it as 0 as the top of my deck, right? I think Sushmita said that the 52nd card was the top of her desk, but again, it's really preference at this point. But yeah, in my card variable, which is to store a card object, I'm putting the first card in my cards list, right? And then what do I need to do? I need to remove it, right? So cards dot remove let's take a look at what that told us it did. Removes the element at the specified index of the collection. That sounds perfect. I'm going to pass it 0. So remove the card at the 0th index, and I'm going to return card. Cool? Yeah? Do you guys want to test this out? We can test it out. So I have a system, or I have a my deck, and if I were to store into delt card my deck dot deal, what should I expect to see in delt card? Let's check it out. So whatever the first card in my deck was, which I think was an ace of clubs, was it? So I had my dealt card. Let's take a look at what it is. It's an ace of clubs, right? I'm going to step down and check out what my deck looks like. And it looks like my deck now only has 51 cards because that card was removed. All right. Any questions so far? Good. I'm going to remove these breakpoints. So we have a deal method that takes the topmost card, removes it, and returns the card. Give the deck a reset method that resets the card's property to contain the original 52 cards. So let's go back. And I have a good idea for what I want to do here. Let's say we call it public void reset. And what this is going to do is it's just going to regenerate all of my cards. So now, in my constructor class, what can I do? Call reset. And that's done, right? So I have one method that resets my cards whenever I want, but when I first instantiate a deck of cards, I'm going to want to dealt a deck of cards anyways, right? Cool. So give the deck a reset method that resets the card's property. Did that. Give the deck a shuffle method that randomly reorders the deck's cards. This one's going to be fun. I think we did something with the Fisher-Yates shuffle yesterday, right? We're going to do the same exact thing. So public void shuffle. What should I do here? I'm going to need a random object for my Fisher-Yates shuffle, right? And
2 of hearts.
Hmm?
Random object, like a random card.
When I say random object, I mean the actual type or class random, and it's going to store in rand this random object, and we can use the .next method to yeah. Does anyone remember the Fisher-Yates shuffle? No?
I sort of do. Like you start out like you create a temp that you'll use in the shuffle, and then like you.
We need that for the swap.
Yeah.
That's going to happen. The swap is an integral part of the Fisher-Yates shuffle. Yes, but where do we swap to? We need a swap index, right?
You can go. You have to you can go for each index.
Mm-hmm.
And then you get a random number of where you want it to go, and then swap between that random number and that index, and then go to the next one.
Mm-hmm. 0 to, let's say, 52. Oops, I need a dot. Next. Yeah?
But we have to go through.
So I need a for loop now. You're right. I need a for int I equals 0. I is less than what? Cards dot length, or sorry, it's counts for lists, -1. And I plus plus.
Is it safe to assume that when we do shuffle, the card is always going to be 52?
Sorry?
Is it safe to assume that the card length is always going to be 52 when we do shuffle?
No. You're absolutely right. So what should we put here?
Cards length.
Sorry?
Cards that count.
Cards dot count. Here?
Yeah.
Sorry, I misunderstood you, Chris. We can expect that our deck will always be 52 because we're dealing with a standard deck, but it won't always be 0. We probably want to shuffle from the I's position. So as our